let's take a few minutes and look at the solution to this AP Statistics free response question, which touches upon sampling distributions. So the context of this question, we have high school A and they're concerned about losing state funding, and that funding loss depends on whether or not attendance on a particular day that's randomly selected exceeds a given boundary. So to lose some of its state funding in the subsequent year, more than 140 students must be absent on the day of the attendance count. So basically, to put context into my answer, I'm using the words in the stem of the question to describe what's happening, and now I'm going to define my variables. So X is the daily number of absences at high school A, and we're interested in finding the probability that that daily number exceeds 140. Well, in the stem of the question, we are told that X is distributed approximately normally with a mean of 120 and a standard deviation of 10.5. You could write it in symbols or you could write it in words. X is distributed approximately normally with a mean of 120 absences and a standard deviation of 10.5 absences. So now we can just take that probability statement and turn it into a z-score. So instead of the probability of X greater than 140, I'm interested in a z-score that's greater than, take the 140, subtract the mean, divide by the standard deviation. So that z-score is approximately 1.9. So now the probability that z is greater than 1.9, that's around 2.9%, 0.029. That's something that we can calculate using the normal CDF command. So I'm interested in being above the 1.9. So the 1.9 is actually going to be the lower boundary, and the upper boundary, because we're working with z-scores, an upper boundary of 10 would be perfectly sufficient. There's where the 0.029 came from. So then I finished with a concluding statement. The probability that high school A will lose some state funding is about 0.029. It's very important to remember to put context into your answer even when it's an answer about calculating something. So now a different plan. In Part B, the Principals Association in the state suggests that instead of choosing one day at random, the state should choose 3 days at random. So with this new plan, high school A would lose some of its state funding in the subsequent year if the mean number of students absent for 3 days is greater than 140. So we're going to randomly select 3 days, and if the mean is greater than 140, that's what would trigger a loss of state funding. So now the question, you're not technically asked to calculate the probability that we would lose state funding in this scenario. You simply have to decide, would high school A now be more likely, less likely, or equally likely to lose funding using this suggested plan compared to the plan in Part A? So you need to state your choice, and then you have to justify it. So you can justify that in terms of words, or you can use a calculation to do it. So I made my choice. High school A will be less likely to lose funding using the suggested plan compared with the plan from Part A. So here's my description in words. The standard deviation of the sampling distribution of the sample mean. Look at how carefully I wrote that. This is important. If we're going to work now with a sample mean, we need to think about the sampling distribution of the sample mean. So remember, the formulas for that are on the formula sheet. You don't have to memorize everything. So the first page of the formula sheet has the descriptive statistics at the top, some probability formulas come next, then probability distribution formulas here, the binomial and geometric ones. On the second page then, for a random variable involving sample proportions, here are the formulas for sample means. I'm interested in a sample mean. So here's my sample mean, and here's really what I'm interested in. The parameters, this is the mean of the sampling distribution of the sample mean. The population mean will be in the center of the sampling distribution of the sample means. What I'm really interested though in is the variability. AP statistics very often boils down to comparisons involving variability, calculations involving the natural variability that occurs when you sample, sampling variability. So this is the formula that I need to consider in my question. So the standard deviation of the sampling distribution of the sample mean, and in context, it's the sample mean number of student absences. It's now going to be that 10.5 from above, but divided by the square root of 3, the square root of the sample size. That's about 6.06 absences. So this is smaller. This smaller standard deviation. This is smaller than the standard deviation from part A. So the result is that sample means will tend to be closer to the true population mean of 120 students. So we have less standard deviation around that 120. Sample means will be closer to the truth of 120 student absences, and it will thus be less likely to observe a sample mean of more than 140 student absences. If your sample means tend to be closer to the truth, it's becoming now more difficult and less likely to get sample means that are more extreme than 140 student absences. So if you wanted to, you could calculate it. So the probability of a sample mean, that's x bar, greater than 140, well, that's, if I change this into a z-score, that's my same 140 like above. I have to subtract the same mean of 120, but notice the standard deviation for the sampling distribution of the sample mean is 10.5 divided by the square root of 3. So this gives me approximately now a probability that z is greater than 3.3. I rounded that z-score. And if you put that into the normal CDF command, that 3.3 is the lower boundary. Again, we can still use 10 as the upper boundary. So clearly you know the z-score is larger. So now my probability is going to get smaller. Recognize then what we get on the screen is scientific notation. This is 4.8 times 10 to the negative fourth. So you can write it in scientific notation, although I would want you to know what that means. 4.8 times 10 to the negative fourth. If I round that to 5 times 10 to the negative fourth, this is really a probability of 0.0005. Now, something interesting. If what you do is calculate this probability and stop, you won't get an E on this section. Even though the calculation is correct and the probability is correct, you have to continue in order to justify that we're less likely to lose state funding. You have to specifically compare your new probability of 0.0005. You have to compare it to the probability from part A. That's 0.029. So it's because of this comparison that high school A is now less likely to lose funding using the plan that's suggested by the Principals Association. So, in other words, two ways to think about this. If you want to calculate the probability, that's fine, but then make sure that you show the comparison. That's what's justifying that now you're less likely to lose funding. If you want to write about the decrease in variability in words, that's perfectly fine. The standard deviation of the sampling distribution is going to be smaller because I'm dividing that population standard deviation by the square root of 3. But then you can't just say that there is less variability. What does less variability actually accomplish? Well, what that says is now the smaller standard deviation, what that tells you is that the sample means that you're getting are going to be closer to 120. Because the smaller standard deviation makes your sample means tend to be closer to 120, that means it's now less likely to get a sample mean more extreme than 140. So you can't just talk about the decrease in variability. You have to talk about what that decrease accomplishes. It means that now, using a sample mean, we're going to be closer to the real population mean of 120, and that's what makes something more than 140, a sample mean of more than 140, less likely. So the last part of the question, don't assume that the last part of the question is typically the hardest part of the question. So in this case, it's actually easier. So a typical school week consists of the days Monday, Tuesday, Wednesday, Thursday, and Friday, and the principal at high school A believes that the number of absences tends to be greater on Mondays and Fridays. So this person's concerned that the school will lose state funding if the attendance count occurs on a Monday or a Friday. So here's the probability to calculate if one school day is chosen at random from each of 3 typical school weeks, what is the probability that none of the 3 days chosen is a Tuesday, a Wednesday, or a Thursday? So I'm using probability notation to describe and to rewrite these events. So it is important that you either use the word probability or you use probability notation. We want the probability that none of the 3 days chosen is a Tuesday, Wednesday, or a Thursday. Well, what that means is I want the probability that all 3 days chosen then are a Monday or a Friday. So none of the 3 days chosen being a Tuesday, Wednesday, or Thursday, what that means is that all of the 3 days chosen are a Monday or a Friday. Well, Monday or Friday, that's 2 days out of 5. Well, that's 2/5 times 2/5 times 2/5. And I can multiply those probabilities together. A Monday or a Friday for the first randomly selected week, a Monday or Friday for the second, a Monday or Friday for the third randomly selected week. I can multiply those together because the selections each week are independent of one another. And 2/5 times 2/5 times 2/5 gives me 8 over 125, or about 0.064. So summarizing my answer then, this is about calculating a probability. So even when it's a calculation question, put it back in context. The probability that none of the 3 days chosen is a Tuesday, Wednesday, or a Thursday is 0.064.